Today is the 2nd of August in the year 2021. Please write your date. And we are continuing with that topic of states and changes of states of matter. Okay, I assume we've done what I've said. By the end of this lesson, I expect that you should all be able to understand that a change from one state to another involves either heat gain or heat loss. I advise you to write that statement at the top because it will guide you on what notes you make. As we go along, yes, the activities we do shall be written in our exercise books, right under the dates that you've written. But also, there are some points you'll find that you are interested in from the slides as you learn. Please note them down in your book. Do not wait for me to tell you that now write this or write the other, just like we do in school. So we hope that by the end of this lesson, all of us will have understood that a change from one state to another involves either heat gain or heat loss. Now, there are a few things we've got to understand. When we talk of change of states, what do we mean? In the previous lessons, we looked at the states of matter. Although in the introduction, we looked at 4 states, that is gas, liquid, solid, and plasma state. For the subsequent lessons, we concentrate on the 3. That is the gas, solid, and liquid. And those are the ones we're going to look at. So a change of state occurs when matter is transformed from one state to another. And it is important that that substance does not change. You should notice that the substance itself does not change, but only its state changes. We shall look at a few cases. Maybe one very common substance in our environment is water. You can have water in a liquid state, you can have water in a gaseous state, and you can have water in a solid state, but it is still water. Now, for you to change water from one state to another, whether it is gas, solid, liquid, there will be energy involved. Either the energy is absorbed or being released. So those are the things we've got to appreciate as we go on. Now, recall also from the previous lesson that we said, when energy is applied to a system, it affects the kinetic energy of the particles in that system. And the first thing it does, it increases their kinetic energy if you have increased the heat energy. When you increase heat energy, the kinetic energy of the particles also increases. So that's what we are saying. The higher the temperature, the higher the kinetic energy of the particles. The converse is also true, that the lower the temperature, the lower the kinetic energy of the particles. We are going to see therefore, when heat is put to this water, what happens to the kinetic energy of the particles? And when heat is removed from the water, what happens to the kinetic energy? Now, we are doing this exercise in our books. Right there, you're going to write that question. It's revision of primary school work. We are going to name those statements, those states of matter. Please copy that diagram in your book. I'm giving us about 3 minutes to have completed that. So can we all start? Put it down in your notebook and put answers. We are going to share the answers shortly. Tamali, your hand is raised. If you have a question, ask. If you've completed that exercise, wait until that time when I call for answers. Let's give our colleagues a chance to finish. So you can ask your question, Tamali. Yes, Tamali. Tendo. Okay. Can you lower your hand if there's nothing to say? Those who are just coming in, copy that question in your book and answer quickly. We are about to start sharing the answers.
Yes.
Okay, we are going to start sharing the answers. I hope we are all done. Can we raise our hands, those of us who are done? Okay, Hosanna is done. Others, when you're through, please raise your hands. That is good. I think about 10, 13 people have raised their hands. Raise your hands because I'll pick people at random to answer. Now I told people to rename. I see an Atamba Moses. My dear, can you rename or else you'll be removed? We don't have Moses in Diaza. Okay, let us start sharing the answers. When I call on you, you give an answer for the number we are talking about. Don't give us all the answers. We shall go step by step, the answer to number 1, 2, 3, and so on, okay? Katsime Grace, the answer to process number 1.
It's melting.
Very good. So we have our melting there. Maybe let me ask a teacher to help me select. Mr. Ajuna? Mr. Ajuna, could you select those to answer? We have 20 girls whose hands are up. But I want to ask, does it mean the rest don't want to talk or you don't have answers? This was an exercise for all of us. Can I see more hands up? Teacher Martha, can you help in selecting?
Okay. Nawami, you can unmute yourself.
Number 2 is evaporation.
Very good, Nawami. Does everyone have evaporation for number 1? Let's hear what the others also have.
Nanyanzi, unmute yourself.
Yes. For number 3, is
No, number 2, Hosanna. We are still on number 2. Someone has given us evaporation, and I'm asking, did you all write evaporation? Did anyone have something different?
Yes, we all wrote evaporation.
Really?
Yes.
Yes, teacher. We all wrote evaporation.
Okay. I want someone who has something. Those of you who have spoken all wrote evaporation. I know there is another term that can be used for the process occurring at stage number 2, where a liquid turns into a gas. Okay, you wrote evaporation, but can we think of something else? Yes, please.
Teacher, vaporization.
Vaporization is similar to evaporation. I'm looking for another term. Maybe let's imagine if you have water in a pan at home and you heat it, there will come a certain time when you call your mother, when you think the water is ready. Will you say, Mommy, the water is evaporating, come? Which term will you use?
Steaming.
Javi.
Yes,
Boiling.
Boiling.
you will use the term boiling. Very good. So when a liquid changes into a gas, it can be doing it through evaporation or boiling. The two are not exactly the same, but they do occur. So that's what we have on number 2, boiling or evaporation. Let's have someone give us number 3.
Charity, admit yourself.
Number 3 is condensation.
Very good. Number 3 is condensation, or I use condensing. Number 4, girls, you're marking your work, and please add some points which you could have missed. Number 4, what answer do we have?
Alinda Mata, admit yourself.
Freezing. Yes.
Number 4.
Freezing.
Number 4 we are saying could be freezing. Very good. We are left with number 5 and 6.
Anna Chirabo, admit yourself.
Teacher, number 5 is sublimation.
Very good. Number 5 is sublimation. We're doing well. Then number 6, what answer do we have?
Christabel, admit yourself.
Deposition.
Very good. We can call it deposition. Anyone who has a term that is not deposition? The rest, I expect our hands to now go down because we're on the last one. So your hand should be up if you're giving us an alternative to deposition.
Sublimation.
Anna, admit yourself.
Yes, someone has just said sublimation. That is very true. Even change number 6, where a gas changes directly to a solid, can be called sublimation. For our case, we will call it resublimation. In most cases, it occurs when the when the gas had already sublimed, and now even the solid can also sublime. So that is what we have for number 6.
Excuse me, teacher.
Yes, please.
Sure.
Who is talking?
If number 6 you can say sublimation. Number 5 can you also say like deposition?
I think either of them can be resublimation or sublimation, but deposition is strictly for number 6.
Okay.
It's a term which can be used alternatively there. Okay, so thank you, my daughters. Whoever got that correct, please pat yourself on the back. We are going to look at each of these processes in more detail. I still see some hands up. Please, if you don't have a question, lower your hand so that we proceed. Thank you. Hosanna, are you up for a question? If it's a question, you ask. Those asking, okay. Mercy Akampurira, can you ask your question? Have we lost Mercy? Kayesu, do you have a question? Ask.
Yes, teacher.
Yes, please.
I have a. You have to write resublimation, or you can just say sublimation. Like, is it also okay?
I have let me repeat myself. Sublimation can work, resublimation can work, and deposition. Okay, thank you very much. Chirabo Pal, your hand is up. Do you have a question or we can proceed?
Teacher, I have a question for number 4.
Yes.
You also call it solidification.
Oh, yes. Thank you for reminding me. Yes. Number 4, we can have freezing or solidifying. That is very good. Thank you, Pal. Okay, can we mute and proceed? Because when your mics are on, you give feedback. Kayesu mute, Akugiziwe mute. Okay, we shall proceed. Now, we are going to do a group activity. Having understood the different changes, that is the activity we are going to engage in for just 10 minutes. Although 10 I think is much. We will go to our groups and do that. So can you take screenshots or copy them out quickly? Copy those questions out quickly. Please, when you get to your groups, get there and start working. I like it when I find people working already in their groups. Gives me that you're hardworking girls, okay? I've given enough time to have the questions copied. I'm about to open the rooms. Okay, you can go. Get there and start business.
Teacher, how are we going?
Teacher, I was in a room, then it just brought me back to the main session. I don't know why.
Really?
Yes.
Yes.
Sorry, sorry.
The main session.
Hey,
Send me back.
okay, now I'm
Teacher, can we are back? Teacher.
Teacher, what are you doing?
Hello, girls. Your colleagues have gone to the breakout rooms and they are discussing certain questions. Can I have a volunteer here to start the discussion? I'm going to share the screen so that you see the question. But can we start serious business in here also? So those are the questions that your colleagues are discussing. Someone assume leadership and we move on.
Okay, for number one, they say, from number one, it says change from one state to another involves either heat loss or heat gain. And then part Roman number one says, how does heat loss affect the kinetic energy of the particles that make up matter? I think that heat loss reduces or lowers the kinetic energy of the particles.
Girls, I've unmuted you. Mute if you're not talking. Okay. You have about 3 minutes to complete this exercise. Your colleagues started already, so can you go over them quickly?
I think for Roman number one, I think heat loss reduces or lowers the kinetic energy of the particles. And then Roman number two, how does heat gain affect the particles that make up matter? I think it increases the kinetic energy. Then the changes of state that involve heat gain, I think we have melting, evaporation, and then the changes of state that involve heat loss. I guess it's condensation and freezing.
What about sublimation and resublimation?
I'm not really sure, but let me first check.
Bravo, Hannah.
Your colleagues are coming back. So we are going to continue the discussion. Girls, you're welcome back. I hope all rooms were closed. Let's wait a little bit for people. You prepare to answer the questions. We go over them very quickly because I know you've discussed them in your various groups. I'm sorry, the option for sharing screen was disabled. But we can still continue. So that is the activity we had. Teachers, are we back? Can I hear from you? Mr. Juna?
I think we are back.
Yes, we are back.
Okay. Thank you. You will help me select the girls. So we are going to go over these questions quickly just to make sure what we discussed is uniform. So How does heat loss affect the kinetic energy of the particles that make up matter? Someone to give us the answer to that? Barnett, you select someone and
On, unmute yourself, followed by Louise.
Teacher, for us to look for the answer we gave was it reduces the kinetic energy of the particles that make up matter.
Very good. Anyone who has something different, or we all have the same?
Can you please repeat your answer?
Someone repeat their answer quickly.
It reduces the kinetic energy of the particles that make up matter.
Very good. Now I want to ask someone a question. If
Excuse me, teacher.
Yes, please.
I was saying that we didn't give a very different answer, but in room 1, we say that heat loss reduces kinetic energy, leading to limited movement of particles that make up matter.
Also, you added something, but I want us to replace the word limited. By limited, what do you mean? Does the movement increase or decrease? Those are the terms I'm very comfortable with.
It decreases.
Very good. So both of you are correct, just that the second person has gone further to say that when the kinetic energy reduces, also the movement of the particles reduces. So that is the question. How does heat loss affect the kinetic energy? Mark yourselves, girls. When the particles that make up matter lose heat, their kinetic energy decreases and they move slower. Very good. We go to the next question. How does heat gain affect the kinetic energy of the particles that make up matter? Barnett, you select someone.
Excuse me, teacher.
Yes, please.
On the questions we had, there was the questions we had actually said that how does heat gain affect the particles that make up matter?
Pardon?
The question that we had said that how does heat gain affect the particles that make up matter? It didn't talk about the kinetic energy.
Oh, sorry. Is that what both of them were like? I'm sorry. Oh, the second one was missing the word kinetic energy. I'm really sorry for that. But let us talk of it in terms of kinetic energy. Thank you for that correction. So in terms of kinetic energy, how does heat gain affect the particles? Someone please answer.
After your Grace, can unmute yourself and answer, followed by Hannah Chirabo.
In room 16, the kinetic energy of the particles increases.
Very good. And they move slower or what? Or they stay fixed in one place?
They move faster.
Very good. I am hoping that is representative of all the groups. Then we had that one, which changes of state involved.
Excuse me, teacher.
Yes, please.
Before you go any further, in my group, we had challenges with the kinetic energy. In my group, people seem not to understand what kinetic energy is.
Okay, then what did you tell them kinetic energy was?
Teacher, according to me, I think kinetic energy is the constant movement of particles.
Oh, that's what you think. Look at it, it has the word energy and kinetic. It is a type of energy. But this type of energy causes things to move. Even you, big as you are, when you move, you possess kinetic energy. It's energy of motion. Okay, does that help your group mates at all?
I don't know.
Pardon the definition of kinetic energy.
I am not giving that definition. You can get a definition from your textbook. I want you to understand. Kinetic refers to motion, okay? In this You people are expected to understand things, not to cram these definitions. Kinetic refers to motion, energy. So kinetic energy is energy of motion. Whenever anything moves, it possesses kinetic.
Madam, if I'm not hearing you well, I don't know if it's my network or yours. Yes, sure.
So we can't hear you.
And we said in one of the other have a lot of kinetic energy. Very well. Sorry, I went off there, but Bennett, can you share your screen? Because I can't share mine now. I've lost rights, or if not, you make me a co-host. So girls, we were emphasizing that bit of kinetic energy and what it is. Thank you very much, Bennett. Yes, a little bit backwards a bit. We have shared all the answers.
Yes, Jason, you can't go greeting grandpa when you're standing.
Bennett, make me a co-host.
Yeah.
Why do you think that daddy lives almost laying down and mommy?
Family and when we are when you talk about family,
you always see mommy.
And when we are
girls, can we keep quiet? Pardon? Bennett, tap on my name and click more and then select make co-host.
I've already made your co-host. I've already made your co-host. You can check.
Okay, thank you.
back house. No, I don't know what back house is.
Sorry, girls, the internet is disturbing us a lot. Okay, we were looking at the states that involve heat gain. I think you had already seen them, so I'll just share them. Can you mute all participants, please? Thank you very much.
Your turn. Teacher Eva is gonna.
Okay, I hope we have some sanity now. Girls, we are sharing the answers there, so you only make a comment if your answers are different from what you got from the groups. But that is what we have agreed on. And so I will move forward Oh, we had already discussed those answers. Those are the changes of state that involve heat gain: melting, boiling, evaporation, sublimation. Then the ones that involve heat loss: freezing, condensing, and even resublimation. They all involve heat loss. Some people have their hands up. Chiravo Pal, no, that one has already spoken, sorry. Let me go to Atkunda Vanessa, ask a question.
Teacher, I wanted to ask, is boiling and evaporation like the same thing? I didn't get you quite well because my network was poor, but I didn't hear.
Explain that. But let us first appreciate that those changes all involve heat loss. Anyone who has seen a change that is in the wrong place and wants to correct? If not, we move on. We are going to discuss all these changes now in details. And you can make your notes as you move on, adding. So that what are we going to discuss on melting? We are saying the melting is that change of state from a solid to a liquid. You labeled it in the other diagram. And we are saying, remember in the first lesson, we said there are strong forces of attraction. We call them intermolecular forces, holding the particles of a solid together. Now, even if they vibrate, they cannot move out of the solid, so they can't disrupt the structure. But when you heat a solid, the particles gain kinetic energy and start vibrating faster and faster. As you continue heating, that heat provides more energy until the particles start to break free from the structure. So they weaken the forces. And once they do that, the solid now changes into a liquid. So to melt a solid, you must put in heat energy. And that energy will therefore overcome any forces of attraction holding the particles and allow them to pull apart. Remember, in the liquid, we said the particles are not as close as in the solid, and the forces holding them are not as strong as the ones which hold the particles in the solid. So the moment the particles start moving apart, then you will have changed it to the solid. Now the energy is provided when the solid is heated up. We discussed earlier that the temperature at which something melts is called a melting point, or we can call it a melting temperature. Vivian, your hand is up. Can you ask about melting before we move to another thing? Halema, the hand has gone. Okay. You ask only about the state we are talking about. So let us go to cases where we see melting in everyday life. For example, you get ice. The moment you put it on your plate, for example, or in your cup, you find it starting to melt. Why is it? And yet for you, you see you have not heated that ice. It's because the air that is surrounding the ice is warmer than the ice. Actually, that air is at a temperature above the melting point of the ice. Can someone tell us the melting point of ice? It was shared here sometime. Our default melting point of ice. Burnett, help and unmute her.
Which I think is 0 degrees Celsius.
Very good. Then who knows the temperature at your home now, even now on a cold day? What do you think in your room, what could the temperature in the room be of the air surrounding you? I have Shugi.
You have unmute yourself. Okay.
Teacher, at my place it's cold, so I think it's 25 degrees Celsius.
Very good. You think it's 25, even if it dropped to 20.
I think it is 21.
Whatever, even if it dropped to 20, okay, girls, mute. Even if it dropped to 20, even if it dropped to 10, those temperatures are above the melting point of ice. That is why when you put your ice in a cup or out of a fridge which is not cold, it will start melting. So we are saying the heat energy required to melt the ice comes from the surrounding air, which will consequently become colder. If you've ever touched around the ice, you find the air there is cold compared to the air elsewhere because the air is giving its heat to the ice and causing it to melt. Very good. Now let us think about ice cream. I know you girls enjoy ice cream. Have you noticed that if you bought ice cream on a hot day, it tends to melt very quickly compared to when you buy ice cream on a cold day? Who can think about a reason as to why that happens? I see some people have raised their hands. Marjorie, share with us. Majo, okay, if you can't do that, I'll pick on Nasolo.
Okay, Chair Hope, unmute yourself.
Nasolo is talking.
Teacher, I think ice cream melts. I think ice cream melts quicker on a hot day because the temperature is very, very, very high. That
Teacher, aren't you hearing me? Teacher.
Kirabo, you were still talking.
Okay, teacher, I think ice cream melts first on a hot day than on a cold day because the temperature that is on a hot day is higher than that's on a cold day. But what I'm meaning, the temperature is normally very, very high. It's like in those 37 degrees and above, normally on a hot day. So the ice cream melts faster than that on a cold day.
Where does the ice cream get that temperature? That's the question I want you to put in. Yes, it's water. Let's mute. Yes, Nasolo, tell us.
So I think that the ice cream melts from the temperature around, from the sun, obviously, because it's hot. And yeah, there are some surrounding things that may be hot and produce that warm air.
Very good. Okay, you've used surrounding things. It's the air. You look at the line above there. We are saying the surrounding air will be warmer on a hot day, or will be hotter, isn't it?
Yeah.
So on a hot day, you have air surrounding the ice cream that is hotter than the air that surrounds the ice cream on a cold day. So since the air surrounding the ice cream on a hot day is hotter, then the ice cream melts faster. Thank you, whoever had thought of that. I couldn't pick all of you. You just know you're wonderful chemists. So that is what we are saying. Ice cream melts quickly on a hot day because the air around the ice cream is hotter on a hot day than on a cold day. So heat from the hot air is used to melt the ice cream. Now I want you to take note of that last statement I'm putting there. Not all solids melt when they are heated. Some may undergo chemical changes as a result of heating. I want you to think about wood. Wood is a solid, isn't it? Who has ever managed to melt wood? When you heat it, instead it changes into a new substance, but it will not melt. So the list is big of solids which do not necessarily melt when they are heated. I just gave an example of paper. It burns instead of melting. I'm moving to another change of state quickly. Freezing. It's the opposite of melting. So it occurs when a liquid turns into a solid. And you can see there the change. You can see the particles are apart in the liquid. And then you correctly said earlier on that the particles lose heat to the surroundings. And so they start moving slowly and get closer together. And then the liquid becomes a solid. The liquid does that. The temperature at which the liquid changes into a solid is called the freezing point. What an important take home here is that freezing is a change of state that involves heat loss. The liquid which is supposed to freeze loses heat. You just imagine when you put your warm water in the refrigerator, you get to the fridge and the fridge is cold and you put there your warm water. That warm water, when you close it in, starts losing the heat it had to the surroundings in the fridge. And eventually its temperature drops, the kinetic energy of its particles reduces, they eventually come closer. And if you come back after some time, you'll find the liquid has frozen. So when a liquid turns to a solid, that is, or when it freezes or solidifies, the particles lose energy to the surroundings. That is what I emphasized. That is freezing. Now, let us think about this. Why do ice cubes form in a freezer? Can someone think about that? Why don't we form ice cubes outside? When you have your plate, you just say a prayer and the water becomes ice cubes. Why is it that it happens in the freezer? Some hands are raised. Bernard, pick them quickly.
Charity, unmute yourself.
Pick another one. She might have issues. You.
Hosanna, then Nalule. Shaggy, one of you. Unmute yourself.
Okay, I'll pick at Kunda Vanessa.
Vanessa?
I think the ice cubes form in the freezer because the temperature in the freezer is really cold. So, yeah.
Thank you, Vanessa. I want you to talk about heat loss and heat gain and particles. I'll be very happy. And change of state. Those are the words I want to hear. Then I'll know you've learned. Hannah, Shiravo Pal Hannah.
Teacher, I think in a fridge there is heat. The surrounding air is actually cooler due to the kind of heat loss, and the water, why it turns into ice cubes is because when the heat is reduced, the kinetic energy of the particles also reduces, making the particles closer together.
Thank you very much, Hannah, or should I say Pal? When we are now talking about change of state, those are the things we should talk about. In the fridge, there is a low temperature. So we are saying when the water is put there, it loses heat to the surroundings, and eventually the kinetic energy of its particles reduce and they come closer, and eventually you turn it into a solid. Girls, I'm only going to discuss this. I can see our time is up. So that is what we are saying. Ice cubes form in a freezer because the water loses heat to the cold freezer. So the kinetic energy of the water particles decreases until the liquid turns into a solid. I cannot go further than that. We will continue with this topic of kinetic and of change of state in the next lesson. Unless someone has a burning question, raise your hand only if you want to ask a question. And then we answer that and move away. Okay, the hands have reduced, but we have 4 hands. Okay, Charity, ask your question quickly.
Excuse me, teacher. So when should we transfer this work in our books to our classwork books?
I thought that is where you've been putting this work. At the beginning of the
So for
lesson,
me, I
you
had
first
notebook.
get your, please, we call them notebook, your classwork book, whatever you call it. Use your chemistry book, put that work in the chemistry book. Those are the notes you have made, okay? Sorry if I did not communicate clearly.
Okay, thank you.
Chirabo, ask your question. Chirabo, no question?
Teacher, I had a question. Okay, based on the way we answer the questions in chemistry, so you're telling us the principle of answering the questions in change of state is that you have to make sure in the explanation there's something that's explaining the heat loss or gain, the surrounding air and the particles in the substance.
That is the content we have learned today, isn't it?
Yeah,
Why
I'll
wouldn't
just-
you like to show that you have learned it when you're answering?
Okay.
So your answering should show that you have attended a chemistry lesson, okay?
Yes.
Please don't answer like you were answering in primary. The last question, Janice Katongole. Katongole, unmute and ask.
Okay, I wanted to ask, is there a possibility that an object or particles can possess more or less kinetic energy? Or is energy just defined as energy, period?
Pardon? We have been talking of having more increased kinetic energy and decreased kinetic energy. So it's not a fixed amount of energy. And throughout these lessons, we have said, when particles have a lot of kinetic energy, they move very fast. Remember somewhere we said the particles in a gas have the highest amount of kinetic energy. Their amount of kinetic energy is different from the kinetic energy possessed by particles in a solid. So when you gain kinetic energy, you don't all get the same amount of kinetic energy, and the amount of kinetic energy, when you gain energy, it can be heat or any other form. When you change it to kinetic energy, it doesn't mean everyone gets the same amount of kinetic energy. I hope I've answered your question, Janice. Okay, girls, thank you very much for attending the lesson. Please come back same time next week. Have a lovely week.